So now let's go back to this topmost plane, the information plane, and discuss some what we believe are nice properties and use cases that emerge from this new approach that we believe Wildland is implementing. So again, this is that the containers are self-defined, and that container can have multiple paths or tags, and that there are no centralized directories or registers. Everything is built bottom-up in an organic way. So first, a very, very simple example is, let's say you have a container for a book. Well, let's say I have a book, a famous book by Robert Nozick. Let's say this container, I say container and you think directory, file system directory. Let's say it contains an EPUB or PDF, or EPUB and PDF versions of the book. And now this container has those categories. So categories are like paths. To a category you add a name and you have a path. So it's data, book, titles, and this title. It's actors, humans, Robert Nozick, and the name. It's timeline, 1970s, 1974, the name, the time the book was published. Topics, politics, libertarianism. A few more, like ISBN, and maybe some more. So this is a manifest of this container which contains the sources of the book.
This is random choice.
Well, these are determined by the very book, but the book I chose is just maybe not so random, but it's just an example, of course. So now if we look at, yeah, that will be. That's a container with this book. And I might have some other books, like maybe Gödel Escherbach by Hofstadter, and maybe a container with my holiday photos. Maybe not all my holiday photos, maybe my recent trip to the mountains, whatever. So you see that in my file system, the Wildland file system, I might have different trees there. Topics, time, places, like Europe, Poland, Tatra Mountains, or Warsaw. Time, like 1970 something. What's the question? Something is not clear? Okay. Topics like philosophy, ethics, or we had, what was there? We had politics, libertarianism, it would be here. We have those persons, humans, actors. This is a different picture. Here is persons, here it was actors, humans, whatever. These are normal trees in my file system. And I can enter through any of those. I can go there and find any of this directory. Well, not a big deal. That's what file systems are for. But again, the change that Wildland brings here is that I can go to this book by any of those paths. Again, you say, well, that's not a big deal because you can actually simulate it even today by creating symlinks. So I really put this book into one, let's say, maybe here. Like I'll go to persons, Robert Nozick, and I create directory for here, and then I create symlinks there. Well, but that's a simulation of what Wildland provides natively, and it can provide it natively because, again, it's the container that defines all the names for itself. Unlike the file system, where the previous directory defines the name, the full path for whatever is in the directory, here it's the other way around. It's the container defining the name for itself. That's why we have it for free that any container can have multiple paths defined. But if you now, we can go even further. If you now imagine these different trees in your file system as different dimensions in some knowledge space, it's a simplification. They don't need to be orthogonal, but they kind of are. Like time, places, actor, they will be pretty much orthogonal. We feel it, right? Some more might not be fully orthogonal, but let's imagine they are. And of course, there are more than 3, but just for an illustration here, we have just 3 dimensions. So you can imagine we can put all this, any of this container in this 3-dimensional or n-dimensional space. And we can go there by just going to specific direction of any of those trees. But now what we can really do is we can do this simple trick and we can dynamically create, we can say synthetically, for any of those 3, add any other categories to make it possible to reach any of the container through any other, taking into account all the other ones. That's okay. Let me show an example. So I go to my, say, data books titles tree, and here normally I would have all those books here, like Anarchy, State, and Utopia. But I also see here synthetically created, which is symbolized by this add. We're not going to use add, but here just for letting you know that these were synthetically created. You can also see, say, actors, and this is repeated from the actors tree. And you go to humans and Robert Nozick, and in there you will see Anarchy, State, and Utopia. Or the same, you can go to Ian Kundera and you will see whatever, unbearable lightness of being, right? But to the same book, you can also go to another synthetically created category, like timeline. So you go to books, you're looking for books, and now you see all the books written in 70s. What's the question, Marek? So you see that I can find this book through any of those paths. And all I need for that is a file system navigation application. So I can have multiple categories for organizing my knowledge, and I can navigate in this complex forest of information using a simple file system. A simple file system which doesn't have a notion of multi-path, of multi-categories. So you can use a finder, or you can use a command line, or you can use Internet Explorer, or whatever. And I think that's very powerful because you can start organizing your knowledge with just a file system. That instead of containers representing your books, you have a container for every email message. So you have all your mailbox exposed as thousands of micro containers, and each container has like time, when it was when the message was sent or received. It has also actors, humans, or just actors, users, whatever, with email address. It might have topics which correspond to the folder, the IMAP folder you would normally put it to. And we'll have data emails, or maybe data mailboxes work, or data mailboxes personal. And suddenly, I get my mailbox available as a part of a file system with all this powerful method of accessing or partitioning this information there. instead of mailbox, I could have calendar events. My calendar event would have the timeline path and the places path and the actors path if it's a meeting. So suddenly all the data sources that we normally think of as of data sources that we consume through different applications, calendar, email client, photos, files with ebooks, maybe bookmarks, maybe my Twitter feed, whatever. All those we can represent as a micro Wildland container, and all of those containers could be integrated in a single file system if I want to. They might, of course, not be integrated. For example, for security reasons. Maybe I'm a user of maybe I want to do some compartmentalization of my digital life, as some of people in this room do often. And maybe I use Cubes OS, and in some cubes I would have different forests than other cubes have access to, and then my data mailbox personal would be in one cube and data mailbox work another one. Or maybe in one cube I will see both of them, but without access to the content of the file, only listing the name of the container. And what we already built already gives you all this possibility, which is pretty amazing, and well, I consider it very powerful. But there is more. So every container has a backend, as we saw on those demos. And if you remember the demo, I think Marek was showing you, he showed you that a single container had two backends in parallel. There was a local backend, and no, it was a backend with read-write access, and the other one was a public backend. But it could have been something different. It could be one backend for storing my files on AWS S3, another one on storing container on, so one backend for storing my container files on AWS S3, another on Google Cloud Platform storage service, yet another one on IPFS, say, yet another one on somewhere, and then Wildland will make sure to replicate all the data on all those containers. This actually is not implemented yet, so this automatic replications, and we're gonna spend some time, hopefully, at the end of the day today on discussing this, because this is one final step for us on the client side before releasing the first public version. But once we do it, let's go back to my example with this knowledge management system, as I call it. So if this is not a book, but your calendar, say, and every calendar even has is represented by a micro container. So we see that underneath there is one backend that is really a pseudo backend, a pseudo backend that really consumes your, say, Google Calendar or whatever, and pretends to be a backend for Wildland, so it produces data, but another backend could be normal storage backend, like S3, or maybe my local file system, or maybe my local NAS, network attached storage. And then Wildland client will automatically, without understanding that this is calendar or whatever, will automatically replicate or backup your calendar data to your whatever storage you chose you want to. Perhaps one of the backend will always be some high latency but cheap per terabyte storage, and it will be attached to most of your containers, and it will always be used for backups somewhere in the background. So all my mailboxes, calendars, whatever that can be represented as a backend, so as a data source in Wildland, will automatically be replicated in the background by Wildland. Talking about backends, there is one more aspect. So you see that backends could be defined in parallel, and this is what Marek showed you today. Like there was a manifest and it was a YAML list. So a YAML list is defining backends like this. Again, this is one remaining step in implementation to do the replication. But while working on this, we also want to combine it with backend stacking. And backend stacking is different by, as you see on the picture, by treating those backends as depending on each other. So let's say this is a normal S3 or simple file storage backend. And let's say this one adds encryption. So this might be ENCFS backend. And maybe this one is integrity protection. Maybe it should be the other way around, or whatever. So you see that once after we add stacking of backends, then we write just one plugin backend for doing on-the-fly encryption. Like we will probably adopt something like ENCFS for that. And then we turn any backend like S3, GCP, NAS, IPFS, whatever, we automatically turn it into end-to-end encrypted storage, which is pretty cool, I think.
For this demo, I will be using just an example database which is not actually from the original app, but it's perfectly compatible with that. We have just a simple generator with which I generate 10 nodes to a file of TMP bear SQLite. For those of you who
just one comment. You know, people who use bear often, like who use bear to organize their knowledge about the world, as I said, they consider the content of their bear database as a kind of intimate. So showing up here and showing publicly my bear nodes would be kind of intimate. That's why we use the auto-generated database that pretends to be bear, but it actually works with the real bear application.
Internally, the bear app is using just SQLite. That's a technicality, but it's actually convenient for us because now conceptually you can imagine that some of the files will be just represented as some rows in the SQL database, and that's what happens here. We have example tags generated. That's what happens on the right side, on the sidebar in the bear app, and also we have 5 example nodes, which are just filled with. Here's one, the last node, and it's just filled with lorem ipsum example text. This node also has its unique ID, which will be important later. So that's what we are trying to represent in Wildland. Without further delay.
So the way it works really is that there are two kinds of containers. There's one macro container.
I will show that in the sequence.
Oh, okay.
So the smart part in that is actually not a container, but the storage which backs up that container, and that's our custom backend, which will be translating those bear nodes to files, and that's what's this. And we need container. container is called bear in my example, and path is the path to, not a path in Wildland, but a path to a SQLite database, which was, I think, this one. Okay, so just to make sure everything's right, we have a container which has a storage with that path over here. Container mount. Okay, so in MNT, I have just container mounted in the usual path. And what we have over here? Here we have our 10 nodes. Each one of those is actually another container, which we have over here. Some basic instruction that we actually need to mount this YAML file as another container. Why is that? Because a single node can have not just the text, but also images, attachments, so everything which will be there will be inside the container. That readme is not that important. It's what's actually I said. We need to mount this container. Okay. We just mounted a container with usual UUID, and under the paths, those are generated from the tags that this node has. And we can go over there, and we have all those tags which are hierarchical. The first one was, I think, this.
Can you do 3?
And we have...
3?
Yeah, sure. But this will also display more of those, also this one, which is not that. And this is the title of the node. This double dot is because the .md is the extension, and the title actually contains a dot at the end. So that's how it's represented. But yeah, and it contains the node content.
Do you want to say something about this timestamping backend?
No, I actually have a demo for this one.
Prepared a demo.
Oh, okay.
With this, I also wanted to show which one of this one. This has a total of 10 directories, which are generated each time from the SQLite database modulo caching, which is also there. So the next thing I wanted to show is that this actually changes when I make changes to the SQL database. I think it was this one. This is a table which contains all those nodes, and I can, if I modify anything inside this. For example,
can you move it up?
Sure. It's
behind, yeah.
I'm sorry. Delete from ZSF node, which is a table which contains all those nodes. I'm deleting just one node. So it's gone.
Ah, nice.
It also works when the node is actually mounted. It gets unmounted.
Oh, because you just unmounted it.
Yeah, but that's not just a stable, and I don't want to show it on the camera because it might crash. But it still works, and so that's actually you can open a Bear app and the Wildland, and you can just edit in Bear, and it shows in our backend. Our backend is read-only, but it's sophisticated enough that it detects the changes to the file. So that's it.
Nice.
Thank you.
Besides the fact that I actually am personally a user of Bear and I use it a lot, and it's super exciting that I can expose all my Bear nodes through file system in Wildland, it's also an example of how we can connect other kinds of apps, as I said, calendars, or maybe my Twitter feed or whatever, and expose them as Wildland container or more likely containers.
Could that be used to introduce a kind of backdoor sharing and collaborating on nodes in Bear?
Collaborating is a tricky subject. We'll get there afterwards. For now, it's let's stay with a single user editing this, and others just receiving the edited. So anyway, Marek will show you now another backend, just to show you what backends can be besides being infrastructure backends.
Yes, so I will show you example backend, stacking backend. So I will have two backends. One we've already seen. It's a backend for cat pictures, and it stores a list of files somewhere. It can be local directory, it can be some cloud service like S3 or what else. But this is just a plain file storage. Photos, cats, and we have those cats. But then I can put another backend on top of it that will do some processing. Joanna said an example would be some encryption or some integrity protection, and yes, we plan to implement those too. But for now, we have some simpler proxy backend that extracts some of the file metadata, specifically modification time, and sorts the files based on this metadata. So let me first show you how the container storage manifests look like. Config, Wildland. So we have for containers, cats is like it was before, but I've added another one, a proxy container, which is, let me put it at the top, which has just a path, some daemon proxy, and points to a single storage container. And this single storage container will be interesting because its type, where is my mouse? Its type date proxy, and it points at another container. So the actual files, this backend, it's not it's not responsible for storing files somewhere. It's a middleware to access another container, and yeah, and there is some also link to a container manifest, just in case. Yeah, this is actually important part. So it's using this this inner container and present the files in some specific way. They proxy have a hard-coded layout that sorts file by a date, and we can see that demo proxy. So the effect is that we have directories based on the date of the file. So the files are exactly the same, but the structure is different. And this stacking mechanism is very flexible. We can reorganize files, we can do some processing of the files like encryption. There are many possibilities here.
But these 2020-09 are now inner paths within a container. They are not paths to microcontainers, right?
Yes.
That's
within the container.
Yes, within a proxy container. So
Exactly.
they are not seen by the Wildland as categories.
Yes, if we would like to see them as a categories, we'd need a trick like with Bear, where we have also two drivers. One is generating a container manifest on the fly, and then we mount those containers.
And that would be very cool for this.
Maybe, depending on the use case, but maybe for this organization, maybe yes. But also a separate container for a single file of the same type, of the same category, and with just one path may not make much sense. Well, depends.
Okay.